Brad is a senior product owner of routing security at ARIN, the American Registry for Internet Numbers. Has traveled here from Chantilly, Virginia to join us and speak with us today. This is Brad's third time presenting at NANOG. Brad's first talk at NANOG was called RIR Spring Cleaning, always a good topic, and that was at NANOG 83 in Minneapolis back in 2021. So welcome back, Brad. It's a pleasure to have you with us here today. And I'll let you take the stage.
Oh, yeah.
I said, and hopefully you have the right slides up here in a second.
Thanks, Bill. Thank you, everyone, for sticking with it and coming in after lunch. It's a beautiful day outside. I totally appreciate you coming in here and taking a listen. Again, my name is Brad Gorman. I'm the product owner for the routing security services at ARIN, primary at which is RPKI. And I'm going to talk a little bit here today about why it's important for the community to be ready, why it's important for the RIRs to be ready, because of the growth and uptake and the use of RPKI and the importance moving forward. So what are we going to do? What am I going to talk about today? One, why did we do this? This exercise, this test we called fail open. What are some of the observations that we made during this test, during this cycle? We wanted to make sure that not only the community is prepared, but the infrastructure is prepared for a hopefully never to occur failure of an RIR's repository. Saw some interesting things before, during, and after, and then I have some conclusions of what came out of it, what we believe we saw, hopefully what you saw or didn't see, and then some plans maybe for the future, what steps we might want to take to improve the RPK infrastructure moving forward. So again, what was our objective? The objective is to say, community, RPKI is here, and people are using it. People are using it more and more. More organizations are requiring RPKI for you to make the statements about your resources before you even sign up to do business with them. This could be your transit provider. This could be your hosting provider. This could be fill in the blank. More and more organizations are asking for it, so more and more organizations need to be prepared for it. But the good thing is more and more people are opting to sign up and use RPKI. More and more resource holders are making those positive statements about their resources. And only together as a group, as a community, is it really going to work. So there are best practices and there are RFCs. In the Internet Engineering Task Force, there's a lot of, you must do this, you need to do that. And what one of the primary RPKI functions is to know that RPKI is there, but it may not be there, and to prepare for it. So we are going through, and I'm going to show you what we saw, how we handled the failure, and see where we can go from there. So not only was this a suggestion or a test for the community, ARIN also took it as an opportunity to investigate our infrastructure, watch how it performed, see what we wanted to see, and maybe see things that we didn't expect to see. So that's why we did this today, or excuse me. So when you come in and you start looking at RPKI, there are always things to consider. And I mentioned in the IETF, there's the RFCs that you must, you should, you may. But best practices are the kinds of things of like, you might, you probably should. It's a good idea if. So if best practices are looked at and understood, there's no adherence to them. But if you use them, good things can come out of it. Best practices come out of lessons learned, whether it's an operator who has encountered a problem in the past, or something learned during your signing up with a service, or possibly order of operations and making it work. That's where these standards and these best practices come forward. And the RIRs, or sorry, the IETF and the RFCs, they were written a long time ago. And we as a community, the RPKI community, has learned more about how does it work? How does it apply today? And that's what BCPs are for. That's why we run through tests to make sure that everybody is ready. So the goal, just be prepared. In the RIR infrastructure, there are many components. RIR serve as the trust anchor for all of their resources they've been allocated within their service region. That's critical because we run these repositories of information that are pulled from, their data is fetched from them, so that operators can make better routing decisions, for their policies and based on additional information that RPKI provides to them. There's also in the community a service or a set of community developed software. It's critically important to making RPKI work. And without that component, you can't get to the next step, where technology vendors have to be prepared and code so that their technology works and benefits how RPKI functions and making the routing security concept good for everyone in the community. And finally, it's the operators like you who use this data and make decisions on whether you want to base your routing decisions on origin validation data that RPKI provides you. So in ARIN, our infrastructure, it's built in a way that it is multi-redundant. Certainly the importance of the infrastructure is there, but we want to make sure that there is no one or two or potentially three things that could happen that would interrupt your ability to come to ARIN, look at the repository, and continue using RPKI uninterrupted. So we load balance between multiple providers. We have multiple sites where we put our gear. We have a capacity of an N+2, so we have the opportunity to do maintenance that will be completely impactless or non-impactful to people who use this data and use this information. We're in geographically dispersed locations. The ARIN service community is North America, Canada, United States, a portion of the Caribbean islands, minor outlying islands associated with the United States, and Antarctica. So if you go to Antarctica, know that you're going to be using ARIN resources while you're down there. But the infrastructure itself that we have is spread across our North American footprint. We use multiple connectivity partners, and different ones at every site. We use multiple co-location providers, so one impact to major co-location facility or co-location provider across won't impact. And then we use multi-vendor technology inside of our infrastructure. So you can see that the desire and the effort that we've put into it to build a redundant system it's apparent that we're looking out for you and your ability to use this data. So what were some of the goals that we had in mind when we went to run this? Well, it was twofold. We were looking for goals for the community and then internal goals from ARIN side. So what were the external community goals? We wanted to take a look and see who was coming in, where were they coming in from, what kind of technology were they using, whether it's the validator infrastructure, versions of code, supported or unsupported. We wanted to really take that inventory of how it's working today based on previous assumptions and based on whether things moving forward in the future and new ideas have been applied into how operators are installing and using the software. Looking at the different configurations and how they looked when these systems were coming and knocking at the door inside of ARIN. And then measure the process and volumes of the information as it was coming in. Who is coming in really fast? Who is coming in looking like a typical, what we would call typical operator of a resource, of validators, of looking in for the information. And then ultimately, we wanted to see what would happen after the fact. You know, sure, turning things down and things go the flat line down at the bottom. Nobody can get there from here. But when the infrastructure gets turned back up, what happens? What's the load look like? What is the performance? What is the profile of what's coming in and who's coming in? What are they doing? So these are all of the things that we were looking for on the coming from the outside. Inside, however, we wanted to make sure that we are providing the best possible value service for you. We wanted to make sure that not only are we following the rules, which rest assured we are prepared for this unthinkable, potentially never going to happen event that could be very impactful for everyone. So we wanted to catch how the different protocols that are used in RPKI were coming in. What is the use pattern? What is the use case? Why would somebody do it one way versus the other? We wanted to look at if people were coming in and there were challenges with what the fetch, where you pull the data from a repository. What would that look like? How did we respond in the case of load? We wanted to see how long it came, when things come back in and we open the door and traffic rushes in, how long did it get back to normal? What did normal look like before? What does normal look like after? And then more than usual, we had our ear to the rail. We wanted to make sure that there was no chatter of something, hey, something's wrong at ARIN. You know, what, my RPKI is not working. My routing has been affected. What's going on? Just to make sure that we were, one, prepared to start responding if something were to happen, and two, see if it didn't happen. See if nobody noticed. And that's what we were hoping for, is that this exercise could be run and everybody's doing the right thing. So what did we do? We call this exercise fail open. And this is the third time we've run this in as many years. The fail open name that we gave is based on the fact that from the outside world, no one could see the ARIN repository. The trust anchor looked like it was gone. It looked like ARIN was dark. From the inside, if there were users of our tools, whether it's the web interface to get into RPKI services, whether it was the RESTful endpoint that people were using that could, you know, they use to make their decisions and use RPKI, those functions still were available to users. But during a period of outage, what happens? Where is it going to go? Where does this traffic go? How does it look like to the outside world when one component of this new, excuse me, not new, but one component of this routing security feature isn't available anymore? And what, you know, really, what's going to happen? So fail open happened on October 24th of last year. We schedule it for a 2-hour window between, you know, the early hours of the afternoon, not during any holiday periods, not during times when, you know, folks would be taking their kids to school, not during the early hours of the morning when you weren't available, when Knox weren't available, staff wasn't switching over. We wanted to make sure that it was at a reasonable time of the day and also enough people, everyone would be available to accommodate whether it was work that you saw that you needed to do from your side, whether ARIN was going to be available from our side, be able to get things done and help you out. So we did it 2 to 4 Eastern time. We did an incremental loss of capacity and protocol connectivity. There was 60 minutes of the first hour. The first hour of the 2 was blocking access to the current largest use protocol, RDP. We left the rsync protocol up and running so people could still get in. The experience was different protocol, but we wanted to make sure everything was working with that one before we shut things off. And then there was a 60-minute period of, you can't get there from here. After that 2-hour window, we brought everything back up all at once, and it's off to the races. So we set a baseline. We took a number of snapshots of the way things were prior to it. And at the 2-hour window before failopen, we registered 3,417 unique IP addresses coming from unique validators, sources, coming in and communicating, communicating with ARIN to say, I'm pulling data from your repository. Then a little bit less than 10% of these IPs, these sources, were also using simultaneously the rsync protocol. That is something we would have expected. RDP is preferred first. It happens, it checks first. And rsync is typically used as a failback mechanism since the development of RDP, but it still offers the same functionality, when it gets down to it. You pull the data. But one thing we did see is that there were 75 different versions of validators that were knocking at the front door. Now, there are not 75 different developers. There are not 75 different software things available out there. But what we see is that from those developers, there are multiple versions of software going back many years in the development cycle that are still being used. Some of the products are listed there, not fully conclusive, but these are ones that had a more than negligible number of hits coming into the system. But what we saw that was a little disturbing, but we knew it was out there, is there were 70 different types of patterns of traffic coming in that wanted to be talking to RPKI, wanted to be talking to the front door, but they weren't really validators. And they weren't attempts to do RPKI. So what were these? What was going on? Get into it in a little bit. We were looking at where our systems were sitting at steady state. So that was our first steps of us preparing to understand how our infrastructure, how ARIN's infrastructure was going to work. And again, ear to the rail. We wanted to make sure there was nothing going on, no major complaints. The internet was running smoothly. Earth hadn't cracked open. So once we knew all of these things and gathered all this, we were ready to go. Talking about the validators. So the development community makes all of these things and all of these tools that we all use. We all should be using, and we should all be using RPKI. Sorry, get off my soapbox. But as you can see, of some of the some of the operators, some of the applications, 34 different versions of one vendor's operator, or the validators being used. 34 different versions. 11 versions of another validator no longer supported by the developer. So what's happening? Why is this really happening? Well, are we benefiting from, hey, some of these folks are writing software that's great, it's bulletproof, it's worked for years, why do I have to update it? I don't know how many times you come up with a piece of hardware that might be 8, 9, 10 years old, running really, really old code, but it works. Why am I going to fix it? Why am I going to pay to upgrade it? So this software is working. But some of the other traffic, hey, you know what? This pattern of the different versions of operating systems and software, it looks like what's on your PCs and what's on your Macs out there. Some of them really old. I never updated, never patched. That's what we've got working here. A little bit of an eye chart, and I'm sorry, I'm going to give you a few more later. By manufacturer, developer, there are only a few that really are made a noticeable level of traffic that came in. It's a little disappointing. We don't want to single thread. We don't want to go one vendor. So it's important that there are different developers of the software out there, and we should use them just to make sure, just to get that second set of assuredness that it's going to work. So beforehand, we started looking at requests that were coming in. Are these connections coming in at a regular flow of rate? How are things doing? What does it look like, and how are we accomplishing getting the job done? The numbers were nice and smooth. In any minute, on any second during a minute, glacial incoming traffic. We have two different repositories that we provided ARIN. Our hosted repository, where people come in and say, in hosted RPKI, ARIN, do it all for me. Just give me a method and vehicle to use RPKI and create my route origin authorization, the ROAs, making the statements about your resources. You do everything else for me. And then there is kind of a slice hybrid option where an operator decides that they want to have more control and features available to them with regards to controlling their certificate authority, their signing of their resources, but they don't want to run that repository. So in this case, we have the hosted repository and an RPS, our repository publication service. So what we're seeing here is things were just moving along just fine, trucking, it was great. We were looking at the like activity coming in. RDP and rsync, like I said, are the two protocols that are used in RPKI. And there are like types of communications between them. In RDP, there's a concept of snapshot. Snapshot's exactly that. Give me a picture of the whole of everything. And then there are deltas, where are periodic updates, typically smaller in scale. Rsync looks like snapshots every time. That's how it works. Give me the full picture of the database, download it to me, thanks. But again, what you're seeing here is the numbers of the requests coming in, pretty glacial. Things aren't changing, no problems being detected. Took a look at our systems that are responding to these different protocols. RDP, rsync, they're not really being overloaded. They're just kind of hanging out there. They're doing their job, listening to everything that's coming in, happy as can be. But some of the things we found were really surprising. Let me get into that. So in a perfect world, if you're an operator and you're making decisions based on origin validation data, and you're really important to you and you really want to use this data, you want to run more than one version of a validator. Now, what we saw was many different locations using one. What we saw were many different versions of the software that we would not have expected to see. And those are really old release candidate software, actual beta in the name of it. Operating systems or versions of software that are literally years old. They still work. People are still using them, but maybe you should think forward. Are these validators up to standard? Are they functioning with new information from new standards that have been developed since they were written? But we also saw an enormous number of web crawlers and bots that are just, we know they're out there, we know they do their thing, but indiscriminately, they're coming and hitting the ARIN's repository. Now, what I'm showing you here is from the 2-hour before period. We were looking for what typical behavior is. And typical behavior is what we would expect to see. Come in, knock on the door. I'm going to look at ARIN's 2 repositories. I'm going to check to see if any major changes have happened. No, they happen. I'm going to pull a delta. And I'm going to pull that delta once. So over a period of 2 hours, this particular organization here running, unfortunately, one validator, has been following basically the best common practice, right? Every 5 minutes, pull the information, look for updates, otherwise things are going normal. Afterwards, we go back and look, same interval. So this is set up as just out there as what most people would consider as typical deployment. Here's some atypical behavior that we saw. So, like I was explaining, when you come in and you want to talk to the RPKI system that ARIN has, you want to go to the repository and say, hey, give me the information that you've got. If I have old data, I'm going to do a snapshot. If I have relatively close data, frequently or recently pulled, I'm going to pull a delta. But what we're seeing here is a site coming in, running a old version of a validator, doing nothing, just knocking on the door really fast, not pulling any information, doesn't care. So really, why would you come knock on the door over a period of 2 hours every quarter second? There's no reason. Updates aren't happening anywhere near that fast, but they're not caring about the updates and clearly see it. So was this somebody who was trying to do something bad? Is this somebody who set up a system 6 years ago when they were working on their doctoral thesis? Who knows? System's up and running inside of a lab somewhere. Nobody knows. Another type of atypical behavior. Here we have an operator that, thank you, running a couple different versions of validators. I like that. Oh no, I'm sorry. This one is running the same one, but before and after, hey, you know what? It's hitting the interval way too fast, at least what we would expect. But not only is it coming in fast, it's asking for the same file over and over and over and over again. And I'm sorry, you don't need to pull 25 different versions of the same update. It's not going to change. So why keep pulling it down? So this is another thing. Why would you pull multiple fetches on the same thing? Is this somebody, again, who set up a test system? Is it stress testing? What is it doing? We just don't know. One of the things we also noticed here is that this particular site was only pulling from one of our 2 repositories. So you're not getting a full picture of what's at ARIN if you're doing that. Message received. Someone needs maybe a little bit further education on how it's going to work. So the next few examples is something that could closely be approximated as, hey, you're doing something right, but what really are you doing in this picture? Why are you doing it this way? So here's an operator running 2 different validators. Yay. But those 2 validators are configured to run very differently. Again, the numbers are small, but what it basically is reporting here is they've got one validator out there running a version of software relatively recent. I'm happy for that. But it's set up in a way that says, give me every update as fast as you possibly can and give it to me 100 times every minute. You know, it's just silly. You know, why do you want to do this? But then a second system set up from the same source is following a pattern that we would expect. Few requests, only pull the update, pull it once. So why is it different? Why does this operator have these 2 things running this way? We don't know. So we're going to track through with this particular customer here, this particular operator that's running these systems. So in the hour after the door was opened back up, after the dark times, what we see here is very similar use rates, very similar rates at which knocking on the door based on 2 different systems. And they're functioning at a very different method of coming in. They're still doing infrequent pulls from one, frequent pulls from the other. But in those, the representation of the requests that are coming in is what we're expecting to see. Things have been gone for a long time, so I need to pull all of these updates. My data is old and I want to see it all. So what's being represented here is the fact that all of these RRDP protocol snapshots are happening. It says, please, I have this serial number that's really old. I know what I have is stale. Give it to me. Give it all to me. Thing is, pulling multiple copies of multiple serial numbers of all of this data, what is it going to buy you? And then having a second system that's doing it once in a while, as you would expect. So really, why are you doing this? Why are you pulling in different cycles? What is the purpose? Why, you know, we don't know. 2 hours later, what we see is that this operator did look at both of ARIN's repositories. The hybrid repository, the publication service that we offer. looking into the serial numbers, really, that's the only way you can tell what's going on and which one's being pulled. But even within an hour, you can start to see that hybrid repository, I'm getting my updates, everything's great. And I'm going to slowly walk away and just come back and say, I got my snapshot, start giving me deltas. But there's disparity between the two here. One of them hasn't looked at one repository at all. The other one who's pulled its update says, all right, fine, I got what I needed. I'm going to just start pulling general updates, those deltas. But they're both trying to hammer out there and get the bigger repository. It's taking a lot longer than they might expect. The responses are a little bit slower, but they're happening. We're giving the responses out there. But again, that polling interval, why? 3 hours after. The rate at which these systems are fetching is slowing down. I'm not going to pull 50 copies of this one. I'm only going to pull 25. What's the difference? Not twice as many, I know. But the fact that they're slowing down and saying, okay, maybe I need to really look at this and say, this update is important. Here's the serial number. I'm going to update this serial number. I'm going to hold back a little bit. I'm going to make sure that what I'm getting is good and that I don't need to go out there and knock on the door so frequently. But it also could be indicative of it taking a little bit longer to get the response that they're looking for. And they're kind of backing off a little bit going, all right, maybe I'm doing something a little silly here. But then you see the second version, again, I seem to have settled down. I'm pulling one copy, one download of each of the old serial numbers that are there. And that's pretty common to have multiple copies going back multiple revisions of a repository based on the serial number, just to resolve anything that's in between them. But going after it once rather than 20 times makes a whole lot more sense. But still, why is there this disparity between the different versions that this operator is running? We don't know yet. So the numbers are starting to go back up again. Why? Well, you can start looking at it and say, well, responses are getting back to me more frequently, so I'm going to ask again at a higher rate. What you're also starting to see is deltas creeping in. So these systems have gotten to a point that says, all right, fine, I have enough recent copy of what I'm working with that I'm not going to keep going out there and downloading everything all at once. So because of that, the amount of data downloaded to them is smaller, and therefore they can ask for more updates. Numbers are going back up. Again, one version chatty, the other not so much. Five hours after, what we're looking at is things are really starting to settle down. Many fewer snapshots, mostly deltas coming in. A clear indication on the number of requests from the chatty version saying, okay, I'm getting my updates fine, things are talking to me faster, I'm going to ask faster because that worked before. But in general, what this is representing is the system is calming down. The rush of the traffic has calmed down, and more people, example here, are getting in and getting what they want in a timely manner. Continuing through time, you start to see no more snapshots coming in. Very few. The difference in the fetch rates are back to where they were before, but they're also different versions pulling the same serial numbers of these databases. So they've kind of come back into line with respect to what they're asking for and when they're asking for it as, hey, here, I need this update. But again, crazy numbers. Why are you doing this? Why? Continue asking. 7 hours ahead, things are flowing. We're seeing it settle down to normal, almost no snapshots, and 8 hours later is really where we find that this particular operator here and the validators that he's running are back to pre-event levels. 8 hours. Didn't break, still served responses, but it took 8 hours to settle back down. I scratch my head. Why? So this is representative of before, during, and after. I think it's pretty clear to tell where the test was happening and access was gone. But comparatively, between the two protocols, the RDP and the rsync protocol, they pretty much followed the same glide path. The difference with rsync is the fact that it stayed up an hour longer. And you can see when the first hour happened and RDP went away, rsync took the traffic. Here you go. And it did. It took it. It happened. Everything still worked. Maybe slower than what you would normally experience, but it worked. And then afterwards, the like requests coming in, the snapshots, the RDP requests, they all look the same. Systems are back to doing what they want to do. They're busy, but they're doing it. And everybody is getting the information they want, they need, but maybe just at a slower rate than what they expect. Between the sites, the multiple sites that we have, you can see as well that there are indicators that systems are running pretty hard. We're getting all of this data out to you. We're working on it. Hold on, we're getting it to you. But there's a disparity between the two of them, and that's just by virtue of the fact that ultimately, once the RDP protocol starts asking for deltas, the data drops down. rsync is constantly asking for a full update. That's why it's busier. What's that drop? What's that arrow pointing at? Well, about 2 hours, hour and a half after we brought the lights back on, we detected a network instability. Nothing inside of our infrastructure that we saw, but it was a switch in providers, traffic going across at every one of our 3 sites. Still curious as to why that happened. But the volume of traffic during that period of time stayed the same. I mean, how can that be, right? Well, seemingly we're getting to a point where systems are only pulling updates. They're not pulling the full load anymore. Things are looking good. Hey, that's great, whatever. You know, all things full steam ahead. Whatever happened out there in the internet, when it came back, as you can see, traffic goes up. But notably, you can see the graph starting to generally flow down and to the right. Sorry, finance people, down and to the right in network load and traffic and system utilization. That is a good thing. And then over time, this chart is an 8-hour-long time frame. Once you get out to the right-hand side, there's some odd deviations and bursts of traffic. Things are returning to normal, or have after 8 hours. 8 hours. But it worked. Nobody was broken. Nobody complained. RPKI did what it was supposed to do. If, and we didn't detect any, if there was someone who attempted to pull an update that failed, they didn't complain about it. We didn't hear anything. Nobody started complaining on a message board. No one was calling into the ARIN service help desk. It worked. We went through and had a catastrophic event happen, and it worked. So what's changed since October 24th? Things haven't changed. There are still many versions of validators that are out there running. There are, again, versions of validators that the developer stopped supporting 3 years ago. Please, community, go to a supported version of your validator, because I guarantee you those developers don't want to hear from you. We all know what the idea of end of support. But the versions of software have changed in 3 months, 4 months since that happened. Newer versions have been developed, new features have been added. And while it still looks like there's wild disparity, and there is with the versions that are being used, people are updating, which is good. Are there early adopters that are doing this? Maybe. people certainly hang back. But are they applying from bug fixes or additional features, right? This is what we're seeing here, and this is what we would expect. Some of the same people are there, hitting us like crazy rates. But there's some new ones too. New semester started. New students running tests. Some of the same crazy loads coming in. But it's out there. It's still working. So what did ARIN take out of this? Well, we saw and we experienced ourselves some of the heat of what was going on, what was coming in. There were already plans in the works, in progress, and nearly complete, bringing our infrastructure even to a higher level of service, a higher standard, an even better, more reliable product to give to you. And we have seen that in these new configurations, what has worked, what has benefited. We've developed new ways and new design formats and new templates to put on these things to make it work even better. It worked, but we're making it work even better. Whether allocations on systems, whether it's processes, memory, whatever, storage space, we're making it better for you. And we also learned that some of the things we were looking for and monitoring, it was good that we were looking in that. But we also found things that we hadn't actively been looking for before that after we scratched our heads, we really need to keep an eye on this, and we are. Our tooling infrastructure has been updated, modified, better focused on the types of things that will maintain this high level of service that ARIN provides the community that uses RPKI. So what are some of the last things that I want to get out and let everybody know? We're taking this data and we're reaching out to some of these people. You know, really, why were you doing it this way? Even if we can find somebody who's going to respond, because in some cases we haven't. Put out a request and it's to University of ABC. It's in a lab somewhere. They don't even know what we're talking about. Oh yeah, that's an IP address on our network. No one's touched that machine in 2 years. Okay. Clean up your installation. We're asking the software development community. It's a tight organization. We all work together. We work on the standards together. We interface with each other in more than just protocol here to protocol there. So what are their plans? Well, how are they going to take this kind of response and this information back and go, well, we know that we're writing the best stuff now. We know that we're moving towards the future. We know RPKI is changing and we're preparing for it. But how is it that we're going to get people to drop off of this ancient, decrepit, gray-haired, wrinkled, and no, I'm not looking in the room, because I got them too. But how do we help those people understand that they could probably come up to the new feature, provide that new service, fix that bug? We're talking to our brethren, sister RIRs and say, hey, you know we've been doing this. Here's what we found. Is that what you're seeing too? Are you seeing something different? And why? Because the RIR infrastructure, that community, we're working together in a way that we want as a whole RPKI to succeed and work better. And to that point, the RIRs have agreed to come together and we have a common working group. We are working together to develop and provide a better infrastructure for everyone. Not just ARIN's members, not just RIPE's members in Europe, not just LACNIC's members in South America. We want everybody to have a better experience. What do you want us to do? What do you want ARIN to do? We answered all your questions. We responded to all your requests. What could we do better? We listen. We have many different vehicles of making those requests come in. Make them. Tell us what we're doing that you would like us to do differently, or we're doing something that maybe you think it could be done better. What did you see? What did you experience when this event happened? I'd love to know. We'd love to know. Because there was no complaint flood. There was no rapid request for information to come in and say, wow, ARIN, you really caused me some problems. Didn't happen. We want to know what you saw, what you experienced, because it'll help us to identify, hey, maybe something can be done better. Maybe this feature needs to be developed. Maybe this tweak needs to happen. But we need to hear that from you, because while we serve a community, that community tells us what to do. We don't tell you what to do. Ongoing, it's a group effort, right? One of the things that's priority 1A for me is education and making sure people understand what RPKI is, the benefit of it, how it works, and a safe manner in which you want to deploy it. But it's not only me, it's your provider. It's your service that you're signing up for. It's the person who's transferring your bits across the world. They know too. They've been working with this as well. Feel free to ask them questions too, because they have good answers. They have different answers than what I can give sometimes, and I'll ask them just the same that I'm asking you today. The idea of doing this work and developing tools, it's a community-based effort. Standards don't write themselves. It involves people coming and being interested and paying attention and getting involved. Get involved. You have control over what direction you want ARIN to go to. If you're an ARIN member, vote. Suggest policy. Make suggestions. Ask for help. We're here. But the key is you just need to participate. And the more of us that participate, the better it gets for everyone. So please, we're here for you. And I'm here for you for RPKI, sorry. Once again, tooting my horn. RPKI is here to stay. It's not going anywhere. If you don't have somebody today telling you you have to create rows for your resources, you will tomorrow. So if you start down the path of trying to understand what RPKI is, and I know it's a 4-letter acronym, but it's not evil. Sometimes it's hard to read standards. Sometimes I read them to go to sleep. But ask. There are many people who do understand. But you have to be prepared, because it's coming if you're not already doing it right now. And the fact that global operators are now making decisions on validity data that they compile from RPKI data. Service providers are making it happen. You're not going to go into a co-location facility or a hosting facility and not be asked to sign up for RPKI and create ROAs. I'm sure some of you in the room have already encountered that. And the benefits of actually using RPKI, examples of how it stopped or mitigated or eased the circumstance where there was something wrong, whether it was a misconfiguration by one of us at 2:30 in the morning when we're pasting a new config, or whether it was somebody who was out there up to no good or bored. Maybe some of us do that too. But the benefits are there. There are examples of them out in the public. You don't have to search hard. They're there. So I encourage everyone to consider, learn about, and decide to make that decision, because it's not just for you, which it is for you, in an effort to protect your resources, but it's for everybody. Because for more of us who make those decisions to say, I want my resources to be viewed in a good way, people across the world can listen to you and say, okay, this is the way you want it to be. This is the way we'll handle it. So what's good for one is good for another. So let's make it happen. Thanks. Do you have any questions?
I actually had a question. Phil from Cisco. I was curious if you plan on doing these events again, or is this a one-time effort?
Well, this is the third time in 3 years, and I envision that these will continue to happen. And 2024 is a new year, so read between the lines.
That was maybe a follow-on question is, what kind of coordination do you have with the community, or is the idea to not coordinate that?
That's actually a really good question. When we did it the first time, it was well publicized. ARIN is going to do this, and everybody around the world heard the words that ARIN's going to break their trust anchor. They're going to mess up my networking. They're going to kill the internet. Second year, there was a reasonable amount of understanding of when it was going to happen, not exactly at the moment it was going to happen. This year, I had hoped to be completely in the dark, so no one could prepare. But information of the knowledge of it really came out a couple days ahead of time. So there wasn't a mass preparation or mass monitoring setup. So yes, we're going to do it again. Yes, we have had to have varying levels of information being shared with the community, but I envision we're going that same direction. So next time, may not happen. Question on the right. Nope. Oh. So I was going to go back and forth. I'm sorry.
Okay. Yeah, Daryl Newcomb, independent. Just to make sure, it was a super simple question. I think I interpreted the slides right. You had a diversity of 75 different, category or producers.
The number of validators coming in, knocking at the door. Yeah.
And did it go to, was it 147? Is that something sound approximately right? I think that's what I saw on the slides.
So what you're seeing is, and let me go back to the slide because I want to make sure I'm speaking to the right one. So the after the fact numbers.
Well, the one that was like 8 months later, I guess.
Oh, okay. So the latest one. I'm sorry, I'm hitting the button far too fast. It's a little slow to respond. There we go.
Faster than 8 hours.
Yeah, faster than 8 hours. Okay, so after the fact. Yeah. So that 147 number, those are the people knocking on the door that are not validators.
Oh, okay. Gotcha.
They are, the RPKI and the RDB protocol looks like it is HTTP, right. HTTPS. And you come in, we're a website for those crawlers come in. So just new things happening.
Okay, thanks.
Sure thing. I'm sorry.
That's okay. Adair, Internet too. Is there a list that is behind a login or something of the validator IP addresses that are misbehaving? Is that something that I can assign my coworker to chase down as well?
It is not something that I am at liberty to share at this point. From our perspective, we're going to reach out to some of these people to try to understand why the pattern of the things that are going on, but no, we can't.
Okay, thank you.
Sorry.
Hi, Andrei Rybachevsky, Global Cyber Alliance. Regarding this abnormal behavior of validators, have you reached to the developers and shared some of this behavior, some of the data you collected?
Absolutely. I mean, what we have seen is what is here has been shared with people as they've asked. This is the first time publicly it's been kind of like put out there. But
Have you got any explanation from them?
I would let them respond to that. I don't feel comfortable answering for them.
Okay, thanks.
Sure. Sorry.
Hey, Marcus. Whoa, way too close. Marcus Jackson from AWS.
Marcus.
You mentioned there was no impact for anyone that reached out. I was curious how many entities reached out to you just to say, hey, we noticed something's odd.
There were a couple calls that came in that said, we know you were doing this, and we had a question about it. When those calls came in, we had some relatively long conversations, and both of them were comfortably answered as being, it wasn't directly involved with the work. Because this work was dedicated to the hosted infrastructure and the trust anchor, that when a trust anchor goes away, effectively no updates can happen, right? So whether an organization is using a hosted product that ARIN is running all of the bits and pieces, the other flavor of RPKI deployment, which is used but in a much smaller volume, is delegated RPKI. So a delegated RPKI is somebody who runs their own certificate authority, handles all those X509 look-like web access certificates, right? That's how the chain of trust is established and maintained. Those delegated repositories still have to talk to ARIN to say, okay, match this up. Is this bit of information that an organization has created in Aroa is true and correct and it was created by the right people? So delegated still needs to talk back to us, and what should have happened, or what I heard happened in those examples, is that information it stayed in the cache that was available at the time. There were no new updates. That's absolutely true. Routing since the repository was gone and ARIN wasn't responding, what happens in the validators, for those who are not familiar, they maintain a cache of data that is used by the operators when they pull it out, and you compare, RPKI and BGP information. Since that data wasn't updating, you could argue very comfortably saying, getting older, maybe getting a little stale as the internet changes and the ebb and flow happens. Maybe this data is moving a little bit further and further away, and that's true. So of those two calls that came in, and wink at me, Marcus, I know you're one of those calls.
You know we were ones.
Yeah. I think it came down to a point that we were able to come together with an agreement that it wasn't a direct responsibility or direct action one way or another. I'll talk to you afterwards.
Yang Yu, Meta. This test mostly cover connection failure. I wonder what your thoughts are on certificate authority related failures, like manifest mismatch, CRL expiration. Like currently the validator softwares handle those failures. Like each has a different implementation or knobs on how those failures are handled.
Right. So in this particular case, I mean, and typically the manifest times are measured in numbers of days. So that kind of information wasn't going to go stale or invalid or get lost and say, oh, I mean, ARIN's completely off the reservation here, and I can't validate anything in the pieces. And since validators themselves cache all of the information that they have, so long as those much longer windows of time associated with the other components, like you're talking about inside of the RPKI infrastructure, there would not and was not, mass failure reported. Did I answer your question?
To clarify, this is more on the content being published. Like I think right now in ARIN's repo, there's still object with the expired CRL.
I'm sorry. Okay. Yeah. So I got a minute and a half. Last year, ARIN made a decision to start auto-renewing objects, being rows that are in the database. And historically, objects have an expiry timer. You know, they rest in peace when they get there. So rows that were in our database that were created through the UI back in time, we scooped all of them up at that time and started auto-renew. There are examples of things that are not auto-renewing, those that were created with an API that we developed and released in 2014. At the same time we started doing auto-renew, we released a new API, and rows created with that new API do auto-renew, get the benefit of that. There is a very small subset of organizations that we are reaching out to actively right now that have ROAs that were created before times and created with this old API that still have expiry dates associated with them, just so that we can understand why they haven't changed things over, why they haven't renewed recreated ROAs that are now all going to auto-renew. So if you're on that list, you are on that list, and you're going to be getting contacted.
Thank you very much, Brad, for the great talk.
Thanks, Paul.